Okay, so staying within the idea of dilations, I can't talk this morning. So we know with scale factor that things can become larger, and that means that the scale factor is greater than 1, or they can become smaller, shrinkage, and that's when the scale factor is less than 1. So in these notes, it talks about if the dilation scaling factor K is between 0 and 1, that the result is a smaller image. So that language can be very confusing. Many people would talk about this as a shrinkage by a factor of 2, implying the reciprocal, a division by 2, or a multiplication of 1/2. The language builds on the idea of reduction in size, but it can be confusing. So it's better to just refer to this dilation as a scaling factor of 0.5 or 5/10 so that you kind of eliminate that language that can be confusing. So what does that look like? So there again, if we have our original image of something like this, and I'm really kind of estimating right here, right? And we have a D and 5/10 dilation, that means that it's going to get smaller because that scaling factor is less than 1. So there again, that's kind of going back to our 7th grade topic. So we've got A prime, B prime, C prime, and we have a smaller image from our pre-image because our scale factor is less than 1. All right, so let's kind of practice this. So let's look down here at our example of a dilation. It says, give the dilation of x 0.8 negative 2 under D3. So what this means is we're looking here. This is a dilation. That's what the D means. So dilation with a scaling factor. Oh, I can't spell scaling. Scaling factor of what? Where do we look for our scaling factor? We're going to look right here, right? So I have a scaling factor of 3. And it doesn't tell us that the origin is any, or the center of the dilation is anywhere. So that when there's no indication, it's going to be at the origin. With center of dilation at origin. I'm going off your page, so let me kind of move it over. All right, and what's that going to look like? This just means, this D3, remember that means that we multiply each of those values by 3 to find out what the new point would be. So x prime, our new point, is going to be k times x and y times x. Okay, and that's going to come from our original point. Let me move my 7th grade notebook out from underneath of there. That might make it easier for me. So x prime, we're just going to go through and we're going to 3 times 8 and 3 times negative 2. Means our new point, x prime, is going to be 24 and negative 6. So our pre-image is the point at 8, negative 2 with a dilation of 3, making it a bigger point, right? A larger on this coordinate plane point. And we're going to multiply each of those values of the point by 3. So 3 times 8 is 24, and 3 times negative 2 is negative 6. And that is our new point. Let's look at a next example. So this says, give a dilation of x 8 negative 2 under D3 to 3.23. So let's walk through all of that. So once again, the scaling factor is what? it's 3 because of this little 3 right here. But the center of dilation is now not the origin, but at points 2, 3. All right. So what does that look like? We want to find the center of the distance from the dilation. And I'm going to tell you guys that this is going to be pretty advanced. You're going to see this in geometry. You're not going to see this as much of what we are doing right now. Okay. So if you want to know more about this, with this point not being in the origin, come see me. But I'm going to kind of leave you wondering and leave that open. Actually, I'll put it on Google Classroom. I'll put a section of this notes on Google Classroom if you want to see it. But I'm not going to bother most of you with this, okay? Because that's going to be a topic for high school into geometry. I just really wanted to make you aware of it. All right, let's talk about the last thing that's in this section, and that's going to be compositions. So for compositions, you can change several transformations together to make a composite transformation. You're going to use single letter shorthands to write the series. It'll probably help to sketch the intervening temporary images. So you might write the results with multiple annotations of the prime. All right, so we have this point or this shape here, and we're gonna do it something like this. All right, and so we have A, C, B. This is going to be our pre-image. And so it says, let's say, what is the image of ABC under T -3, 3, R x-axis. Well, what in the blue blazes does that mean? Just break it down, guys, right? It says that is, what is the image after the shape is moved 3 units to the left, because this is our X point, and so that's telling us on the x-axis if I'm going to the left because it's negative or to the right because it's positive, and 3 units up. And then it's reflected across the x-axis, right? So you can kind of do both of those, but ultimately we're going to end up something like this. And there again, mind my drawing, it's not precise. But if I've got the original point here, so A, C, B, and we're going over 3 points, so 1, 2, 3, and up 3, 1, 2, 3. So my new A prime is going to be here. My B prime is going to be somewhere along in here. And my C prime is going to be somewhere along in here. Right? So there's our translation. Right? So we've moved the shape. We've slid the shape. And then we need to reflect it across the x-axis. So in doing that, remember that's almost as if we've folded that paper, that axis in half. So our C is going to be here. Our A would be here. And our B would be here. And that's how we are looking at a composite transformation. Just identifying the different steps that go into that transformation. We'll practice a lot on that this week.